Okay, so this question says, find the equations of tangents to the circle x squared plus y squared equals 5 from the point 5, 0. So again, we're just going to draw a quick sketch. So if this is our circle, now from this circle we can tell that the centre is 0, 0 and the radius is the square root of 5 is your radius. So there's my centre 0, 0. And what that's telling me is there's a point outside here. So the point is, say, over here. And that point is 5, 0. And we're saying that we have tangents that go through the point 5, 0. So two lines, they go through the point 5, 0, but they are tangents to the circle. So they hit the circle at one point. And they don't cross it. So obviously that's not what I've drawn, but they're tangents to the circle. So what we know is to find again the equation of the line, we need a point on the line and a slope. And we're really lucky because we have a point that's on the line. So I'm going to sub in, so any equation that goes through the point 5, 0, this is the general equation of the line. We don't know our slope, so it's y minus y1, so 0, equals m, x minus x1, which is 5. So y is equal to mx minus 5m. So if I bring everything across, 0 is equal to mx minus y minus 5m. But that's the equation of any line going through the point 5, 0. I need to specifically find these two lines that are tangents to the circle. And what we know is that if they're tangents to the circle, if we draw a line from the centre to the point of contact, then the distance of that is going to be equal to the radius, so root 5. So we know that these lines are a distance of root 5. So I'm going to use my perpendicular distance formula again. So I know that my line is just mx minus y minus 5m equals 0. So that's going to be my a, b, and c. So a is m, b is minus 1 because that's what's in front of the y, and then c is 5m. And the point, so I know this line, and these are the blue lines in the diagram, are root 5 units away from the centre. So my centre is my point. So that's my x1, y1. So if I sub those into the formula, I get, so a, which is m, times x1, which is 0, plus b, which is minus 1, times y1, which is 0, plus a minus 5m, so minus 5m, all over square root of m squared plus a minus 1 squared. And I know that that distance should be equal to root 5. So just to tidy that up a little bit, so on top I get minus 5m, on the bottom I get root m squared plus 1 is equal to root 5. Now I'm going to just square everything because that will get rid of the modulus bars, but it will also get rid of all these square roots. So that's going to give me 25m squared all over m squared plus 1 is equal to 5. So now I'm just going to cross multiply. So if you want to put that over 1, you get 25m squared is equal to 5 times m plus 1. So I'm just going to quickly do that. So that's giving me 5m squared plus 5. Letters to one side, so bring the 5m across, m squared across, that becomes 20. M squared is equal to 5. So m squared is equal to 5 divided by 20, which is a quarter. Square root, so m is equal to the square root of a quarter. So m is equal to plus or minus a half. So there's two answers here, remember, there's two lines. So what that's telling me is the slope of these tangents, the slope of one of them is positive a half and the slope of the other is minus a half. So if I'm going to use my point, remember that each line goes through 5, 0. So I'm going to use that point and I'm going to use my slope as a half. So that's going to give me y minus 0 equals a half x minus 5. So y is equal to a half x minus 5 over 2. 2y equals x minus 5. So x minus 2y minus 5 equals 0 is one equation. And then the other one, we're going to use the same point, but we're going to use the minus a half slope. So y minus 0 equals minus a half x minus 5. So y equals minus a half x plus 5 over 2. So we get 2y is equal to minus x plus 5. So if I bring the x across, x plus 2y minus 5 equals 0 is my other equation. So in that case, we knew the point it went through, so find the general equation of any line that goes through that point. We're working backwards to find the slope, and the only other piece of information we know is if you have that general equation of the tangent, you know the distance from that to the centre should be equal to the radius. Work backwards, find your slopes, and then sub them back in.